So in this video, we will do a straightforward trigonometric substitutions. That is when your integrand contains any of this form. The square root of a squared minus u squared, the square root of a squared plus u squared, and the square root of u squared minus a squared, where a element of real numbers. So for the first triangle, you have an opposite side equal to u, and then the hypotenuse side is equal to a. So by Pythagorean principle, we have the square root of the adjacent side will become square root of a squared minus u squared. That is square of the hypotenuse minus the square of the opposite side. So we notice that sine theta is equal to opposite over hypotenuse, that's u over a, and it follows that u is equal to a sine theta. So it means that du, differentiating u equals a sine theta, so you have du equals a cosine theta d theta, and it follows that theta is arc sine u over a. And then for the second triangle, the triangle described by an opposite side equal to u, and then the adjacent side is equal to a. And again, by Pythagorean principle, the hypotenuse side is equal to the square of the adjacent side plus the square of the opposite side. So it follows that tangent theta is equal to u over a, and it follows that u is equal to a tangent theta. Differentiating this equation, you have du equals a secant squared theta d theta, and theta is equal to arc tangent u over a. And finally, for the last triangle, that is described by the longest side is equal to u, and then the adjacent side is equal to a, and then the opposite side is equal to the square of the hypotenuse minus the square of the adjacent side. So it follows that secant theta is equal to u over a, and u is equal to a secant theta, and then differentiating this, you have du equals a secant theta tangent theta, and theta is equal to arc secant u over a. Okay, so let's have some examples. Say if we wish to find the integral of dx all over x squared times the square root of 4 minus x squared. So here you will notice that your a squared is represented by 4, and then it follows that your a is equal to 2, and your u square is represented by x squared, and it follows that your u is equal to x. So we have an integrand containing the square root of 4 minus x squared. So if we have, according to the rule, if we have an integrand containing a squared minus u squared, then the substitution that we're going to use is u is equal to a sine theta. So when your integrand contains the square root of a squared minus u squared, then the substitution that we're going to use is u equals a sine theta. So in this case, since we have u is represented by x, so we have x equals a, which is equal to 2, and then the trigo function is sine theta. So we have x equals 2 sine theta. And then on our integrand, we have x squared. So when you square both sides of the equation, you have x squared is equal to 4 sine squared theta. And then you need to have dx. So dx is obtained when you differentiate x, that's dx. So you need to differentiate 2 sine theta, which is equal to 2 cosine theta d theta. And then we change the variable. So we have integral of dx is represented by 2 cosine theta d theta all over x squared is represented by 4 sine squared theta times the square root of 4 minus, again, that's another x squared, so that is 4 sine squared theta. And then, simplifying this trigonometrically, we have 2 cosine theta d theta all over 4 sine squared theta times the square root of, we factor out 4 here, by common monomial factor, you got 4. Then this will now become 1 minus sine squared theta. And do not forget that 1 minus sine squared theta is your cosine squared theta. So we have integral of 2 cosine theta d theta all over 4 sine squared theta, and then square root of 4. 1 minus sine squared theta is your cosine squared theta. 4 cosine squared theta. And then finally we have 2 cosine theta d theta all over 4 sine squared theta, and then the square root of form cosine squared theta is equal to 2 times cosine theta. Okay, and then we can now drop this off 2, and then 4, throw it outside. That's 1/4 integral of d theta all over sine squared theta. And then 1 over 4 integral of 1 over sine squared is cosecant squared theta d theta. And then integrating cosecant squared theta can now be integrated by basic integration formula of the form negative cotangent theta plus c. And from theta, we will write it back to x by using this substitution. We say that x equals 2 sine theta. It follows that x over 2 is your sine theta. And then you draw the triangle. So if this is your theta, this is sine theta equals x over 2. It follows that your opposite side is x and the hypotenuse side is 2. And then this is now equal to square of the hypotenuse, 4 minus square of the opposite, x squared. And then we have negative 1/4. Then cotangent theta is given by square root of 4 minus x squared from this triangle. That is adjacent side over opposite plus c. And then simplifying, you get negative square root of 4 minus x squared all over 4x plus c. So this is the integral of dx over x squared times the square root of 4 minus x squared. Okay, for this type of example, you cannot do a straightforward trigonometric substitution since your integrand contains x squared plus 2x plus 2, and this is trinomial, okay, trinomial in form, and what we need to look for is any of these three: square root of a squared minus u squared, square root of a squared plus u squared, and the square root of u squared minus a squared. So this is of the form x squared plus 2x plus 2. Okay, to make it available for the trigonometric substitution to be available. For this type of example, we cannot do a straightforward trigonometric substitutions since our integrand contains the square root of x squared plus 2x plus 2. Okay, so to make trigonometric substitution available, we have to rewrite x squared plus 2x plus 2 in any of this form: the square root of a squared minus u squared, square root of a squared plus u squared, and the square root of u squared minus u squared. And that can be done when you do the completing the square. So by completing the square, we have dx all over the square root of x squared plus 2x. And then by completing the square, you need to divide this by 2. 1/2 of 2 is 1 square plus 1. And then you copy 2 plus 2. And then since you added 1 here, then you need to subtract it again. And then what you notice is that the first term of the radicand is a perfect square trinomial, x squared plus 2x plus 1, whose factor is x plus 1 quantity square. And then you can now add this to 2 minus 1 is equal to 1. So plus 1. So once more, x squared plus 2x plus 1 is a perfect square trinomial whose factor is x plus 1 square. And then you just combine these two, 2 minus 1 is equal to 1. So now, looking at your radical part, you have x plus 1 squared plus 1. So which means a squared is represented by 1, and it follows that a is equal to 1. And then x plus 1 squared will be your u square equals x plus 1 square. And this means that your u is equal to x plus 1. So looking at our form, when your integrand contains square root of a squared plus u squared, then the substitution that we're going to use is u equals a tangent theta. So we have u is represented by x plus 1. So you have x plus 1 equals a, which is equal to 1 times, then you have tangent theta. Tangent theta. Or that will be simply equal to x plus 1 equals tangent theta. And then you need to have dx. So differentiating both sides, you have dx equals secant squared theta d theta. Okay, and then you also need to have x plus 1 square. So you have x plus 1 square is equal to the square of tangent theta. Tangent square theta. And then you now have dx. dx is secant squared theta. Secant squared theta d theta all over the square root of x plus 1 square is tangent square. Tangent squared theta. And then plus 1. So we have integral of secant squared theta d theta all over the square root of tangent squared theta plus 1 is secant squared theta. And then continue. We have the square root of secant squared theta is secant theta. And then looking on the numerator, you have secant squared theta. And then on the denominator, you have secant theta. So you can drop this up. Okay? And that will become secant theta alone. Secant theta d theta. And then integrating this, you have ln of secant theta plus tangent theta. Then you can now add c. Okay? So, rewriting this back to x using this identity, you have x plus 1 equals tangent theta. So, you draw the triangle. This is your theta. Theta is opposite side over adjacent. So, the opposite side is x plus 1. And then the adjacent side is a. A is represented by 1. So, this is 1. And this is equal to the square of the opposite plus the square of the adjacent side. Okay, so we have ln secant theta. Secant theta from the triangle is hypotenuse x plus 1 square plus 1. That's the hypotenuse. All over the adjacent side happen to be that's 1 plus tangent theta. Tangent theta is x plus 1 over 1 plus c. And then you can just simplify this as ln of the square root of, remember, x plus 1 square plus 1 came from x squared plus 2x plus 1 plus 2 minus 1. And all of this came from x squared plus 2x plus 2. Okay, once more. X plus 1 square plus 1 is equal to x squared plus 2x plus 2. So you have the square root of x squared plus 2x plus 2, okay, then plus x plus 1 plus c. And then you can just ignore this 1 on the denominator. So finally, we have this integral which is equal to the integral of dx all over the square root of x squared plus 2x plus 2. Another example we have is the integral of dr all over r cubed times the square root of r squared minus 9. So looking at your given, we have a squared is represented by 9 and it follows that a is equal to 3. And then your r square is represented by u square. So u square equals r square and u is equal to r. And then, so we have an integrand of the form the square root of r square or u square minus a square. U square minus a square. So again, looking at our formula, so when your integrand contains the square root of u squared minus a squared, then we use this substitution. U equals a secant theta. Okay? So we have u, which is r, equals a, which is 3, and then the trigonometric function is secant theta. Okay? And then you need to have r square. So squaring both sides, that's 9. Secant squared theta. You need to have r cube. R cube is 27. The cube of 3 cube. Okay? And then secant cube theta. And then replacing this, you have dr. dr can be obtained by differentiating this. So you got dr equals 3 secant theta tangent theta d theta. So you have 3 secant theta tangent theta d theta, that is your dr, all over r cube. R cube is represented by 27. 27 secant cube theta. And then the square root of r square is represented by 9 secant squared theta minus 9. And then, okay, simplifying this, we have integral of 3 times secant theta tangent theta d theta all over 27 secant cube theta, the square root of, you factor out 9 here, 9, then secant squared theta minus 1. And do not forget that this secant squared theta minus 1 is equal to tangent squared theta. Then, we have integral of secant theta. You can drop this off and then remove 1 secant here. So, you only have 2 secant squared theta. Then, you now have 3 over 27. That's 1 over 9. You can just write out 1 over 9. Then, what is left on the numerator is tangent theta alone. Tangent theta d theta all over. Then, this secant cube earlier, this will now become secant squared theta. Secant squared theta. And then, the square root of 9 and tangent squared theta is 3 tangent theta. 3 tangent theta. And then, you can now drop this off. So, 3, you can just write out 1 over 27 integral of what is left is d theta all over secant squared theta. And then, this can now be equal to 1 over 27. Integral of 1 over secant is cosine, which means 1 over secant squared theta is cosine squared theta d theta. So, to integrate, we can use the identity for cosine squared theta, which is 1/2 plus 1/2 cosine 2 theta d theta. And then, we are now ready to integrate. So, we have 1 over 27. 1/2 d theta is 1/2 theta plus integral of cosine is sine, and then 1/2, then the derivative of 2 theta is 2, you get the reciprocal of it, so that will become 1/2 times 1/2, it will now become 1/4. Then integral of cosine is positive sine 2 theta, and then plus c. And then, again, recalling this principle, r equals 3 secant theta, it follows that r over 3 is equal to secant theta. Once more, r equals 3 secant theta gives us r over 3 equals secant theta. And then, by using the triangle, secant theta is hypotenuse over adjacent. So, this triangle has a hypotenuse side equal to 3 and an adjacent side equal to 3. Sorry, a hypotenuse side equal to r and an adjacent side equal to 3. And then, the opposite side is just the square of the hypotenuse minus the square of the adjacent side. So, that's r squared minus 9. So, going back here, theta, this theta can be obtained when you get the inverse function of this. So, arc secant, r over 3 is your theta. So, r over 3 equals secant theta. It follows that arc secant of r over 3 is equal to theta. However, this is 2 theta, but this is theta alone, so we can use the double angle identity. So, that will become 1 over 27 times 1/2 theta plus 1/4 times 2 sine 2 theta is 2 sine theta cosine theta. What's that? Okay. And then, plus c. You can just multiply this 2 to 1/4. So, we have 1 over 27 times 1/2 theta plus 1/2. That's 1/4 times 2. And then, copy sine theta cosine theta plus c. And then, we can now replace everything here. We can now write this back to r by using this triangle. So, we now have 1 over 27 times 1/2. Theta is arc secant. arcsecant r over 3 plus 1/2. Sine theta is opposite over hypotenuse. That's your sine theta. Times cosine theta is adjacent over hypotenuse. So we can now introduce 1 over 27, each term here. So I will have 1 over 54 arcsecant r over 3, and then 1/2 times 3 times 1 over 27. So this 3 will be cancelled out. 27 will become 9. So we only have 1 over 18 plus 1 over 18. And then square root of r square minus 9 all over r square, then plus c. So we can just simplify this part or write it properly. That's 1 over 54 arcsecant of r over 3 plus the square root of r square minus 9 all over 18r square plus c.